So I'm just going to show you here how to grease a joint. So I've got a little bit of Vaseline on the end of my finger here, and I'm just going to roll it sort of around the joint like this, just a line around the joint, just like that. No need to put in too much of it, and then that would be greased. So this is the partial setup for the distillation. You'll notice we have a lab jack at the bottom. That's this thing. We've got the mantle here. It's not on yet. That's very important. I mean, it's on, but it's not turned on yet, so it's not doing any heating. Might be best to even unplug it for now. Let's go ahead and unplug it. There we go. And then we'll plug it in when we're ready. That makes sure we don't have any problems. May I have the Kleisten adapter, please? Now, the Kleisten adapter has already been greased. You saw how I did that earlier. And when you do this, always put it in and don't twist it. Just put it in like that, and that way there won't be any air bubbles or anything that will come up through the grease. Doesn't matter so much for this one because we're not doing any vacuum distillation, but it can matter for other applications. So this is how we attach the condenser to the Kleisten adapter. We use a blue clip called a Keck clip. Could you please bring that closer to the camera, Jen? Now you'll see that it's sort of like two parts. It's got a big part and a big inner part, or a big outer part and then a little inner part. Right, they go over the joint in a specific way. So go ahead, and I'm going to zoom in to that as you do it. Okay, so what you'll notice is that the big part of the Keck clip goes around the big part of the joint, and the little part goes around the little part. Right, I'm going to just zoom in a little bit more on that, just so you can see it. So just point to the actual joint where it's joining. Yeah, see in between there? Yeah, that's the outer edge of the condenser right there. So you're just sort of clipping the condenser into place. All right, now we're going to put the collection adapter, and we're going to clip that on as well. And that goes on there like that. So again, point to the joint, please, Jen. There we are. All right, excellent. Now you'll notice we've got a couple of lab jacks set up. Now we can probably do this and get away with just one, but if we're going to have it raised up a little bit, which I don't think is a bad idea for the actual mantle here. All right, so you can just move your hand, please, Jen. All right, I think it's good to have this raised up a bit. So if there's any problem that occurs during the boiling, then we can simply turn it down a bit. Would you please, the other one here, yeah, thank you, yeah. So you can roll that down if there's ever a problem, and at least we have some room to do that. So that's why I think it's good to probably use two lab jacks like that, and then go ahead and you can put it back up now, Jen. Now what goes on top here? What goes on top is a thermometer adapter and a thermometer. Now this is not quite what we need. It's close, but we need something else here that goes in between. You see that thing here? There we go. And this thing here is a thermometer adapter. So what we do is we stick the thermometer in the top of the thermometer adapter like this, and then push the, would you mind doing that, please? In the shot, up a little bit. Okay, so she's going to just go ahead and push that in. There we go, perfect. Yes, all right. And now that should be greased as well, and that goes, now go ahead and stick it in the top there. Now the question is, how far do we stick the thermometer down? All right. Let's see how we do that. So where should the thermometer be? Well, the thermometer should be a little bit lower down, kind of close to here, a little bit lower, just below where it goes through the Kleisten adapter. About a little bit higher. Yeah, just pull out a little bit more. That's smart, taking it out to do it. That's good, all right. And that's about perfect. So about there, I think that's a really good place to have the thermometer just before it goes out through the condenser. Right, when we're attaching the tubing to the condenser, it's probably best to have the condenser off the setup first. So go ahead and attach it. So push it on fairly firmly so it doesn't pop off, and we'll do it on both sides like that. Right, then Matt is going to go ahead and put it back in the actual setup, and then I'll show you how to hook it up. Let's talk about the tubing now. So you can see the tubing is attached to the condenser, and what has to happen is the water goes in the bottom and goes out the top. The intent is to fill the condenser with water. So if it goes in the top, then all it will do is just run through, but if it goes in the bottom, it will fill the condenser and gravity will be our friend. So go ahead, Tina, and connect the lower one to the faucet. Or Cassidy, you can do that. There we go. So it goes on the faucet. All right. Nice. And the other one goes into the sink. Okay. All right. Now I'd like you to go ahead, Cassidy, and turn it on, but we don't want Niagara Falls here. Now what I want you to do, Tina, if you would grab the one that's pointing in the sink, please, and pull it out just so we can see it. And you can get an idea of the kind of flow that we're talking about here. As you can see, it's filling up the condenser now, and now it's coming out. And we just want a gentle trickle. That's nice. I like that. Thank you. Perfect. Now you can see what they're doing to fill this is they're taking off everything there and then just pouring it straight in through the neck of the flask. Yeah, there we go. Don't pour it in through the top of the Kleisten adapter, otherwise we'll end up going down the condenser. Alright, that's good. Let's take that out. Now in that flask they've also put, would you mind actually adding a couple, just a boiling stone please? There we go.
There are some.
Okay. That's right. There we go. So she's put a boiling stone in there as well, and then we're good to go. Alright, so what we're seeing here is it's actually boiling. You can actually see it boiling here. But you'll notice there's not a great temperature rise yet. Well, let's see, it's about 40 degrees what it is now. But you'll notice that it is boiling, but we don't get any real action until the vapor actually hits the bulb, and that looks like that's what's happening right now. So the temperature is going up, and it's getting close. It's around 50 now. And what's going to happen is it will stabilize at around 80. Alright, so now it's boiling pretty vigorously down there, and the temperature, we'll go ahead and zoom in on it if we can. There we go. And you can see it's about 73, something like that. So it's not stabilizing yet, but you will notice, I'm going to zoom out here, that there's already stuff beginning to come over here into the receiving flask. Is that right? Mm-hmm. Yeah. So you can see all sorts of evidence of that. If you look at the condenser, you'll see stuff going through there, and eventually, of course, you can already see stuff dripping through the collection adapter into the flask here being collected. Yeah. Now it's not ready to do it yet. We want to have this stabilized here, and it looks like it's there we go. There we go. It's getting close to 80 here. So we want to sit here for a couple of minutes just to make sure it's not going up any. It may stabilize at 80, it may stabilize about 81 or 82 or something like that. So it's looking pretty good for now. It doesn't look like it's moving at all, does it? Alright, now that it's not moving, that's what you need to mark down in your book as what's it say there in the results? The temperature at the first boiling fraction?
Boiling point constant fraction.
Yeah. So that's the first, this will be the temperature of the first fraction.
Can you read it, Jenny? It is 80.5.
Okay, so it's 80.5 for that one. Alright, now what's going to happen is they're going to, I'm going to zoom out here, and Tina's going to replace that flask with the graduated cylinder. Now she's lowering that so she can get that underneath. There we go. Now the idea is that this is a weighed graduated cylinder, and she is going to collect about 5 to 10 mils of the fraction that's coming over here, which hopefully should be mostly ethanol. Alright, as you can see, we're collecting that first fraction here, and we're going to collect between 5 and 10 mils here. It doesn't exactly matter how much we collect, we're not trying to get exactly anything here. About where are we at, Tina? Can you see?
Almost to 5.
Okay. We'll take it a bit above 5 and then we'll switch it out, okay? Is it just above 5 now?
Yeah, it's about 5 1/4.
Okay, alright, let's go ahead and switch it out. So she's going to switch it back with the actual flask that we had there initially. There we go. See, that will enable us now to take a measurement around about 40 mils in that, and then we've got 45 mils in the flask, and then we've got 5 mils in the graduated cylinder here, and we know that that's when we expect to see the water coming over. I'm going to zoom in on the measurement here. I'm going to put this on the edge, and we're going to zoom in here. I'm going to make sure that we understand how to read this. If you look at a graduated cylinder like this, a 10 mil graduated cylinder, I'm just waiting for this to focus here properly, there we go. What you're going to be doing is looking at the graduations, and there's 5 graduations between the mils, so each one of those is worth 0.2. So if I'm looking at that particular measurement, it looks like it's in between the 3rd and the 4th graduation. So that would be 5.7. So it'd be 5.2, 5.4, 5.6. And the meniscus is between the 3rd and 4th graduation. So I would call that 5.7 mils. So each of these is going to be measured to 1 decimal place. Now what they're going to do is they're going to go ahead and weigh it, and the mass of the liquid will be the difference between the mass of this filled graduated cylinder and the empty one. So we've now taken out the first fraction and we've put the flask back underneath. So it's busily collecting, well, mostly ethanol right now, I imagine. And you can see that what's happening with the temperature is that it's going to gradually hike up here. And you can see it's gone up a little bit. Now it's not going to go up too much initially. It might go up to about 82, 83, something like that. Then once all that ethanol is gone, which you'll be able to tell by sort of eyeballing the volume here in the flask, then the temperature is going to start rising a lot more quickly. And then we're looking for another stabilizing point, which will be somewhere between 95 and 100 degrees, I imagine. That hasn't happened yet. But once it gets to that point, that's when we will take our second fraction. But it has to be stable between 95 and 100 degrees. Right, now that we've taken the first fraction out, then we can turn this up a bit and allow it to get to that plateau that I was talking about, somewhere between 95 and 100 degrees. So this has been turned up to about 8. I think that'll be a good number to get to our next plateau. Alright, so I'm looking at this flask now. It looks like it's got around about 50 mils of material in there, so I'm expecting that most of the ethanol is probably gone, and that now we are going to be close to getting mostly water out of the setup here. So now that we've collected mostly ethanol, you can see that it is hiking up here, and they're going to see if it can stabilize here somewhere between 95 and 100 degrees, and then at that point they're going to start collecting their next fraction. Now one thing that's kind of important here is to make sure you don't run out of liquid that's in the flask. So check periodically and make sure that there's liquid left in the flask. You're not waiting for stabilization at the expense of using up all your liquid. That would not be good. But I'm looking at that, and that looks like it's fairly stable, so about 97 degrees. So let's go ahead and collect the next fraction, please. Now that the temperature is stabilized at about 97.0, they are now collecting their second fraction, and they need between 5 and 10 of this one as well, and they will measure the volume and measure the mass again and get the density of that fraction as well. Once they've collected this, they can go ahead and stop the setup and get ready for the second part. Alright, so we're done with the heating part here for the water, so the whole assemblage is off now. So what's going to happen is we're going to turn this into a fractional distillation by putting the packed condenser in between these two joints. And we'll show you how to do that in a second. Alright, so this is off now, but it's still very hot. So what I'd like Matt to do is go ahead and lower the lab jack, please. So as you can see, there's still liquid left in there. I know it's yellow, I don't know why it's yellow, but it is. Now what I'd like you to do is take that mantle right away from the heat, please. Because even while that's under there, it's still heating it, because heat rises, of course. There we go. So now it's away from it, that's good. Make sure that the water's not dripping into the mantle, please. There we go. That's good. Alright, so we're going to let that cool for a little bit, and then I'm going to show you how we can get this set up. Alright, so now that it's cooled for a little while, we've got everything's been turned off here. You can see the heat's been taken right away from the flask. Tina, go ahead and take the top assemblage off, please. So you'll notice she's taking the entire thing off, and she can lay it flat down on the bench. She's going to be very careful about it though. There we go. Alright, so Matt, what I'd like you to do is take off the flask along with the clamp. Okay, there we go. That still could be pretty hot. And we will put it into, that looks like that cork ring might be a little bit too, that cork ring might be a little bit small. Let's go ahead and use that one. There we go, that's better. So we've got that on the cork ring like that. I think we can go ahead and just pour that liquid into the container that we have here. So this is the same container as we've been using for our in-between fractions. So he's going to go ahead and do that. If you want to, you can also take it over and cool it under cold water in the sink. I don't know if it's entirely necessary. We want to use this flask again for the next step. Okay, that's good. Now you'll notice there's still boiling stones and stuff in there, and that's good. So let's go ahead and add the liquids. We're going to add another fresh set of ethanol and water, 50 mils of each. Alright, that's good. Alright, let's get the whole thing set up again now, please. No, don't put that in yet. No, put the mantle on first. There we go. Now careful of the setup there as well. There we go. Alright. Matt, you can go ahead and clamp your flask, but not too low. Right, just clamp it to the thing. Alright. Now as long as that mantle, make sure that mantle is cool. As long as that mantle is fairly cool, you can go ahead and put the flask into the mantle. Go ahead, drop the flask into the mantle. No, drop the flask into the mantle using the clamp. There we go. There we go, alright. Now it's important that it's not too hot when you do that, obviously, because you don't want it to boil out of there. Alright, let's go ahead and put the packed condenser in, please. The packed condenser. That goes in the top here. It goes in through the, it goes vertical. Vertical. There we go. Perfect, that's good. Alright, lovely. Okay, Tina, go ahead and stick that on top. Yeah, notice how this is clamped only at the flask here, and that's all that's really necessary here. And yeah, you can let go of it, Tina. It should be okay. There we go. So, yeah, see, that's all right. Okay. Now you've got another lab jack there, so you can go ahead and you can raise that lab jack. And we're just really going to be doing the same thing as we did previously. This packed condenser increases the surface area and allows for the possibility of better separation between the liquids that we're boiling here, the ethanol and the water. So we'll see if that actually does happen. You can keep on raising that if you like. There we go. Keep going, that's good. It can go up a fair way. Alright, nice. Now you can go ahead and get started on the heating. And let's go ahead and stick this on about 5 or 6 to start, since it has to get through that packed condenser as well. Alright, so here's the setup. I've taken that flask out and I've just put a clean flask in there. I think that will make it a little bit better as we go through this process. So now we're looking at the setup with the ethanol and the water here, and we've got the packed condenser in between, and we're waiting for it to stabilize here. I'll see if I can zoom in. Yeah, it looks like it's pretty close to 80, and it looks like it is stabilizing, so I think they could probably go ahead and replace that flask with the graduated cylinder and start collecting their first fraction. And before it got to 80, it started boiling pretty vigorously, but nothing really very much happened until we saw or felt the ethanol come up here and get close to the thermometer. But after that, it started to go up really quickly, and now it's stabilizing about 80. Now we're going to stabilize it, wait till it stabilizes again about 95 to 100, and take that second sample.